Dear students, welcome to my channel, Learn to Live. In this video series, we will be discussing 8th Standard Science, chapter by chapter, based on NCERT or CBSE syllabus. In the previous video, we learned chapter 5, Petroleum. Those who missed that chapter, or needed a revision, please watch it. The link is given in the description. Chapter 6. Combustion and Flame. There are a lot of fuels around us. Some we use at our home, some we use in industries. The chemical process of burning is called combustion. In this chapter, we will learn about this chemical process and types of flames produced during this process. We will be learning the following topics in this chapter. What is combustion? How do we control fire? Types of combustion. Flame. Structure of a flame. What is a fuel? Fuel efficiency. Harmful effects on the environment due to burning of fuel. Question and answer session to revise the chapter. So without any delay, let's get started. What is combustion? When we burn things in air, it produces heat, light, and another product. For example, when we burn charcoal or coal in air, it produces heat, light, and carbon dioxide. The chemical process in which a substance reacts with oxygen to give off heat is called combustion. The substance that undergoes combustion is called combustible or fuel. Combustible or fuel can be of any state such as solid, liquid, or gas. Sometimes, light is also given during combustion, either as a flame or as a glow. In the example shown above, charcoal and coal are combustible substances. Now, let us understand more about combustion with the help of some activities. Activity 1. Understanding combustible and non-combustible materials. For this activity, collect some materials like wood, paper, kerosene oil, matchsticks, iron nails, charcoal, stones, and glass. Now, try to burn each of these materials one by one, and note down whether it is combustible or not, as in the following table. Now we know that combustible materials are those materials which react with oxygen to give heat, and non-combustible materials are those materials which will not react with oxygen to give heat. Activity 2. Understanding the role of air in combustion. For this activity, take 2 lighted candles and fix it on a table. Now, cover one of these candles with a glass jar, and you can see the candle stops burning in it. So, we understood that air is necessary for combustion. Activity 3. Understanding ignition temperature. For this activity, collect some matchsticks, paper, and wood. Now, try to burn the paper and wood with the matchsticks. You can observe that the paper will start combustion quickly, whereas the wood will take some time and may even require more than a matchstick to start the combustion. So, we understood that different substances catch fire at different temperature. The lowest temperature at which a substance catches fire is called ignition temperature. So, we can say that a substance cannot catch fire unless it reaches its ignition temperature. Activity 4. Understanding varying ignition temperature. For this activity, take 2 paper cups. Add water in one of these cups. Now try to burn the cups with the help of a candle. You can observe that the cup without water burns, and the cup with water does not. This is because the heat supplied to paper cup is transferred to water by conduction. Thus, in the presence of water, the ignition temperature of paper is increased. So, we can conclude that the ignition temperature of a substance may vary due to the presence of another substance Inflammable substances. Some substances have very low ignition temperature. Those substances whose ignition temperature is very low and can catch fire easily with a flame are called inflammable substances. For example, liquefied petroleum gas, LPG, petrol, diesel, compressed natural gas, CNG, etc. We must be very careful while handling and transporting inflammable substances, as it catches fire easily and is very dangerous. How do we control fire? You might have seen firemen using water from fire engine to extinguish the fire in buildings or houses, as shown in the below picture. They pour water over the fire and the building. The water cools the combustible materials and brings its temperature below the ignition temperature. Also, the water droplets and vapors will surround the combustible materials, which prevents its contact with air, preventing further combustion. We know that the fundamental requirements for the combustion to take place are fuel, air, for oxygen supply, heat, to reach ignition temperature. We can prevent the fire or combustion by removing one or more of these fundamental requirements. Removal of fuel is almost not possible in most cases, as the combustible material can be everything surrounding it. By using extinguisher, the air supply can be cut off, or bring down the temperature of the fuel lower than the ignition temperature. In some cases, the extinguisher plays both these roles. Though water is the most common fire extinguisher, it cannot be used to control the fire caused by electrical equipment or by gases and oils. Water will conduct electricity, increasing the risk during a fire caused by electrical equipment. The density of water is lower than oil, so it sinks below the oil, and oil will keep burning. So in such cases, we can use CO2, carbon dioxide fire extinguishers. It is stored in pressurized cylinders. When sprayed, it acts as a blanket around the fire and doesn't allow the fire to spread. It also lowers the temperature of the fuel. Thus it is more effective than water. Another way is to put dry chemicals like sodium bicarbonate, also called baking soda, or potassium bicarbonate near the fire, as these chemicals will release a lot of CO2. Types of combustion. Combustions are classified into three types as rapid combustion, spontaneous combustion, explosion. Rapid combustion. If we bring a burning matchstick near a gas stove and open the knob, we can see that the gas burns rapidly, producing heat and light. This type of combustion is known as rapid combustion. Spontaneous combustion. The type of combustion in which a material suddenly bursts into flames without the application of any external heating is called spontaneous combustion. For example, burning of phosphorus and sodium in air at room temperature. Explosion. If we ignite a cracker, a sudden reaction takes place with the evolution of heat, light, and sound. A large amount of gas is liberated in this reaction. These type of combustion are called explosion. Explosion can also take place with the application of pressure on crackers, as we see the explosion of bombs in movies. Now, let us learn about flame. Depending on the type of combustible or fuel, the shape, color, and type of flames will change. For example, the flame produced from a candle and a gas stove are different. You can see the difference in the below picture. Not all substances burn with a flame. Some substances like coal burns without any flame. We will learn why it does not produce any flames in the next session. Structure of a flame. How flame is formed. To understand it better, let us do an activity. Take a burning candle. Now bring a glass tube and place one end near the dark zone of the candle flame as shown. Now, bring a matchstick near the other end. You can observe a flame on that end. This happens because the wax gets vaporized while burning and causes the flame. The hottest part of a flame. To find the hottest part of a flame, let us do an activity. Take a burning candle. Now, place a thin long copper wire inside the flame, as shown in the picture for 30 seconds. You can see the portion of wire just outside the flame gets red hot. This indicates that the outside, non-luminous part of the flame is the hottest part of a flame. Goldsmith blows this outer layer of flame with a pipe for melting gold and silver, as this part is the hottest and causes the melting easier. Structure of flame. What is a fuel? The sources of heat energy that are used for domestic and industrial purposes are called fuel. For example, wood, charcoal, petrol, kerosene, diesel, etc. A good fuel is the one which readily available, cheap, burn easily in air at moderate rate, produces a large amount of heat, does not leave behind any undesirable substances. A fuel which follows all these conditions is called an ideal fuel. But there is no fuel which is ideal. So we need to look for a fuel which fulfills most of the requirement for a particular use. Fuels differ by the state, cost, availability, heat production, after combustion waste, etc. Solid fuel examples: coal, wood, paper, etc. Liquid fuel example: petrol, diesel, LPG, etc. Gaseous fuel examples: natural gas, CNG, coal gas, etc. Fuel efficiency. Fuel efficiency helps us to understand how efficient a fuel is for combustion. Different fuels have different efficiency. The amount of heat produced on complete combustion of 1 kilogram of a fuel is called its calorific value. It is expressed in a unit called kilojoule per kg. The calorific values of some fuels are given in the below table. Let us learn about the harmful effects of burning fuels on environment. Burning of fuel causes several harmful effects on the environment. Some are air pollution. Burning of fuels like wood, coal, and petroleum products release unburnt carbon particles in the environment. These particles in environment causes respiratory diseases such as asthma. Carbon monoxide killing. Incomplete combustion of fuels release carbon monoxide, CO, gas to the environment. It is a very poisonous gas. If coal is burned in closed room, then carbon monoxide gas produced can even kill the person sleeping in that room. Global warming. In most combustion process, carbon dioxide, CO2, gas is released to the environment. We know that the increase in the amount of carbon dioxide causes increase in Earth's temperature, causing global warming. Other harmful gases like SO2 and NO2 effects on environment. Burning of coal and diesel emits sulfur dioxide, SO2, gas. It is an extremely suffocating and corrosive gas. Petrol engines emits nitrogen oxide to environment. These oxides of nitrogen and sulfur dissolves in rainwater and form acid. Such kind of rains are called acid rains. It destroys crops, soil, buildings, and organisms. In order to reduce the effects on environment due to the combustion of fuels, these days diesel and petrol are replaced with CNG, compressed natural gas, in automobiles. The CNG produces very fewer amounts of harmful products. Thus CNG is also called clean fuel. Now, let us discuss some questions and answers to revise the chapter. For every question, think for 5 seconds before answering. Question 1. List the conditions under which combustion can take place. For the combustion to take place, the following conditions should be satisfied. Fuel, or combustible, is required. Air, oxygen supply, is required. Heat, to reach ignition temperature, is required. Question 2. Fill in the blanks. A. Burning of wood and coal causes dash of air. Pollution. B. A liquid fuel used in homes is dash. LPG, liquefied petroleum gas. C. Fuel must be heated to its dash before it starts burning. Ignition temperature. D. Fire produced by oil cannot be controlled by dash. Water. Question 3. Explain how the use of CNG in automobiles has reduced pollution in our cities. CNG, compressed natural gas, is also known as clean fuel. Its usage in automobiles has reduced pollution in our cities because it leaves behind no residue after the combustion. It produces very small amount of carbon dioxide, CO2, carbon monoxide, CO, and oxides of sulfur and nitrogen compared to petrol and diesel. Question 4. Compare LPG and wood as fuels. The comparison of LPG and wood as fuels are given in the below table. Question 5. Give reasons. A. Water is not used to control fires involving electrical equipment. Water is not used to control fires involving electrical equipment because it might conduct electricity and may harm the people trying to extinguish the fire or the people near the area. B. LPG is a better domestic fuel than wood. LPG is a better domestic fuel than wood because it is cheap and readily available. It produces a large amount of heat energy than wood at moderate rate of combustion. LPG does not leave behind ashes or undesirable products. C. Paper by itself catches fire easily, whereas a piece of paper wrapped around an aluminum pipe does not. The ignition temperature of a substance vary in the presence of another substance. The ignition temperature of paper is low compared to a paper wrapped around aluminum. Question 6. Mark a labeled diagram of a candle flame. Question 7. Name the unit in which the calorific value of a fuel is expressed. The calorific value of a fuel helps us to understand the efficiency of a fuel. The calorific value of a fuel is expressed in a unit called kilojoule per kilogram, kilojoules/kg. Question 8. Explain how CO2 is able to control fires. CO2 is heavier than oxygen. Thus the CO2 covers the fire like a blanket. This cuts off the contact between fuel, combustible, and oxygen. Hence the fire is controlled. Question 9. It is difficult to burn a heap of green leaves, but dry leaves catch fire easily. Explain. The ignition temperature of green leaves are higher than the dry leaves, because the green leaves have water content inside it. Thus it is difficult to burn a heap of green leaves, but dry leaves catch fire easily. Question 10. Which zone of a flame does a goldsmith use for melting gold and silver, and why? The goldsmith uses the outermost zone of the flame, with the help of a blowing pipe, for melting gold and silver, because it is the hottest zone of the flame. Question 11. In an experiment, 4.5 kilograms of fuel was completely burnt. The heat produced was measured to be 1,80,000 kilojoules. Calculate the calorific value of the fuel. Question 12. Can the process of rusting be called combustion? Discuss. No. Process of rusting cannot be called as combustion, because rusting is a very slow process compared to combustion, and heat produced is very small in rusting compared to combustion. Combustion need an ignition temperature to start the process, while rusting happens in room temperature. Question 13. Abida and Ramesh were doing an experiment, in which water was to be heated in a beaker. Abida kept the beaker near the wick, in the yellow part of the candle flame. Ramesh kept the beaker in the outermost part of the flame, whose water will get heated in a shorter time. Rakesh water will get heated in a shorter time, because the outermost part of the flame is the hottest zone.